All right. Well, hello, everyone. Welcome back to another episode of Composites Weekly, the industry's leading podcast show. Today, we're going to be talking about composite materials in the EV markets. I've got Peter Hedger with Composite Applications Group, and he's been on the show before. He and I got together out at CAMX back in October. Always fun to have him on. Their company connects the dots when it comes to composite technology, meeting with OEMs. He's shared a lot of the work that they do in the past, working with on some of the projects, the Wabash trailer and some of the other projects they've been involved with. He shared that on our last episode out at CAMX. Today, we're going to be talking about composites in the EV. So he generated some really interesting discussion last week on LinkedIn, and I wanted to have him on. He attended the NTEA, the Association for the Work Truck Industry show last week. And Peter, I think you had mentioned that that show was, heavily EV, I'm sure. But one of the striking perceptions that you showed was that, the lack of composite materials or composite companies out there, and including the association, which, I mean, it's not a criticism, but it's like, hey, these are opportunities out here for our industry. So why aren't we here? And I thought that was really good. I want to welcome you. First of all, we'll jump into the discussion, but first, welcome back, man.
Hey, thanks. Always good to be back. It's always good to have a conversation with somebody that knows and is interested and curious about composites. So.
Yeah. So before we get started, I want you to share your background for some of our listeners who may not have heard our last episode. You're the VP of Business Development at CAG. CAG has an extensive and robust network of composite technologies and materials. And you guys really, I love what you do because you kind of network with so many OEMs out there. You're out there connecting, companies with the necessary supply chains to bring innovation to their business model and make them aware. I love you're out there. I mean, that's one of the reasons you're attending these shows, right? You're out there connecting with OEM manufacturers. So
that's the goal. That's the goal.
Right. So give us some background, and we'll jump right into the topic.
Well, I don't know if I can do any better than what you just did. That was pretty fantastic. No, you're right. What we do is we connect technologies to OEMs. So one of the interesting things, and I'm going to lead off on my introduction with a question for you about what are some of the foundational attributes that you would say composites have?
Well, the first thing we think of is, lightweighting, when it comes to so many applications out there, longevity, corrosion resistance. I mean, you can go down the line, right?
No, you're right. That's exactly right. And so that's kind of the lead into to why I think what we do is important. So those are attributes that people like, right? Especially if you can be lightweight, anti-corrosion, and still maintain the strength required for structural things.
Right.
But the problem is that composites, as you know, Jonathan, and I'm sure many of your listeners know, composites are not easy to necessarily build something with. It's a process, and in that process, there are a lot of variables.
Right.
And so it's being able to figure out how do you tune those variables to get the desired outcome and leverage the attributes that each one of those variables can potentially have. And so what we do essentially is we are a company or a collection of companies, a consortium of companies that are non-competitive that connect the dots of all of those different attributes so that when an OEM says, I really want lightweight and strong, and I want to maintain anti-corrosion and all those good things, and we can bring those two groups together, the OEMs and the supply chain for advanced materials.
Sure.
And so where that led me, or where that has been leading me lately, is to explore, and I love CAMX. I love the JEC, and I love composite trade shows. And again, you're going to know this as well as I do, but when you're in a composites trade show, it's the industry talking to the industry.
It's like an echo chamber. Like we hear our own talking points continually, you know,
It's true. And so everybody's super excited about everybody else that's there. But
right.
the problem is that you want other people to get excited and show up.
Yeah.
And so I work with ACMA, and I love that group, and SAMPE, and it's also another fantastic group. And then I also work with IACME quite a bit, and they're great groups. And so I'm not throwing shade on what they're doing. They're doing the best that they can. It's up to us in the industry to help them. It's up to the industry to come alongside them and say, okay, we really need to be able to bring in OEMs that want these attributes. And in order to do that, we really have to go outside to other industries. And John Bussell with the ACMA does a fantastic job with concrete and infrastructure, and has been carrying the Composites flag for forever. And does a really fantastic job at articulating the benefits of composites to outside industries. But there are so many industries, it takes a team effort, and he's only one man. So if the industry came together and began to go out and look at these trade shows like we did at the Work Truck Trade Show, we'd begin to realize there's a gap between what we're saying composites do and the people that we're trying to communicate that to.
Sure.
And the Work Truck Show is an excellent example.
Yeah, I mean, you're absolutely right. And to be honest with you, before you even posted that, I didn't even know about, to be honest with you, I didn't know about the Association for the Work Truck Industry Show, you know.
Well, you wouldn't, but you wouldn't. And here's why. You wouldn't know, Jonathan, because you're not a municipality looking for a garbage truck.
Right. That's right. Exactly. You know, I'm glad this association exists out there for sure, you know. But yeah, I mean, bringing that to our attention is like, okay, yeah, there's other opportunities out there. And you hit on a good point, is like, you know, we talk to ourselves about the benefits, and we express those continually, like we just, you know, laid out to our industry. But when it comes to, you know, stretching outside of our industry, and I feel like sometimes it's outside of our comfort zone because we know what we know.
That's right.
And, but we've got to be able to tell our story to other industries out there, you know.
That's right.
And
there's a proposition. I'm going to put this out there, and this is a little bit selfish, but I'm going to put this out there to anybody that's listening here. I need a supply chain map, and in that supply chain map, I also need a vertical market analysis, and that's what we're talking about here. So identifying a vertical market analysis and identifying how those markets behave and think and act, and what the strengths, weaknesses, and opportunities are. That's going to give us an understanding as an industry to be able to identify the markets that we really need to be targeting. Work trucks would be primary example, right? These aren't the OEMs, even though the OEMs are there. It's not necessarily the OEMs that the Work Truck Show is targeting. They're targeting municipalities. They're trying to sell a Ford Pro truck to a municipality, and they're selling all of the attributes that are common right now, which is lightweight, strong, EVs, all that good stuff. Anti-corrosion, but they're skinning that cat a completely different way.
Sure.
And just to dive right into it, there were a couple composite companies there. Crane Composites, shout out to them. They had a small booth there.
Absolutely.
You were there at the Composite Show, and I didn't see you. I apologize.
No, I wasn't there.
Omnipresent.
I just told you I didn't know anything about it. You know.
No. I mean, other composite companies.
Yeah.
Listeners, but the idea is that there wasn't a solid presence, and so there were, however, and they popped out of the woodwork, several composite companies that were walking the show, which is great.
Right.
And there's an awareness of the show. But what struck me, here's what struck me, and this is the genesis of that post. What struck me is I walked around that trade show, and everything was EV. It was EV chassis, EV skateboards, EV technologies. And I get it. So EV is here. So if you doubt EV and you want to debate whether or not EV is valid, that's great. That's a completely
wrong debate.
And it is a long debate, and it's valid. It needs to be had.
Yeah.
It doesn't matter though for this show. It's there.
That's
80% of the big booths that were there were speaking to it in some shape, form, or fashion because they wanted to be relevant. But every one of those EVs that I saw was probably 5,000 to 10,000 pounds heavier than their corresponding ICE or internal combustion engine.
Sure.
Right. And that's tremendous. And why is that? Well, that's because you have an existing model and they put a new technology into it, but they never changed the model.
Yeah.
Right. And so for an ICE, the way that they build skateboards is great. You put an EV in there and you're adding all those hundreds of pounds of battery weight, but you're not changing the structure itself. You're going to gain weight.
Yeah.
And so all of the fears that EV has about being left alone in an avalanche or being left alone in a rock slide and their power runs out, and they can't just bring a gallon of gas to power up the vehicle to move, or in a snowstorm, right? All those fears of not being able to make it to the next charging station, we can alleviate some of that stuff when we begin to incorporate new technology, or they begin to say, how do we go back to this model and change the model and then put battery back in top of it?
Right. Yeah. Cause I mean, what's the average range right now? But what, 400 miles tops?
That's for a car.
Yeah. For the car. Yeah, exactly. For the car.
For a work truck, it's like 150 to 100 miles.
Sure.
It's not far.
So, there's the issue right there. You're talking about like adding more, obviously more battery is needed for longer range,
right?
But if you're adding more battery, you're adding weight. So, and I want to get, our next guest, and I'm excited to connect you to, I've got a technology guest with Clean Tech Group. He's going to be joining us. He's got he's got extensive background in as an analyst researching emerging materials and technologies out there, market trends. And his name is Anthony Vicari. I'm going to bring him into our discussion, Peter, if that's okay with you. Let's see here, Anthony. Yeah, welcome to the show. I got the banner right in front of you, so I need to remove that. How are you today?
Good, thank you. Good morning, everyone. Glad to be here.
Yeah. Welcome to the show, Anthony. So you've listened to our discussion. Peter was at the automotive show last week, and just seeing the EV. I mean, this. Your background is in, as an analyst researching a lot of this. You're seeing the trends, but we're also, coming up. We're also talking about the need for lightweighting. Obviously, especially batteries. The need for increasing the ability or the range on these vehicles means adding more batteries, which means heavier vehicles. What's your take on that?
So I think that if you're a composites company, then absolutely there's a significant opportunity from lightweighting EVs, just because the automotive market is so big. But if you're a car company, I think you still have to be very selective how much you use in any particular vehicle of any particular composite, just because they are still so much more expensive. And frankly, there's still a lot of room to continue lightweighting, even just with aluminum and better steels. So it's an area where my opinion has evolved a little bit over the years. But if anything, I've probably moved a little bit more in favor of lightweighting recently. 7 or 8 years ago, I would have said, well, batteries are getting a whole lot cheaper. And so there's going to be a lot of cases where you would just put more batteries in a vehicle. But now we're getting more and more concerned about geopolitical implications and increased mining and concerns about the source of critical minerals. And that might change the equation in the next handful of years or generations of cars.
Yeah, that's interesting. Peter, do you have any follow-up? I mean, feel free. You're you're my co-host today.
Yeah, great. So 100% agree. I think the statistics that I've heard are within a year to a year and a half, we're going to run out of lithium. Now, let me qualify that. When I say run out of lithium, I don't mean that there's not enough lithium in the ground to supply the demand. What I mean is there's not enough capacity to dig the lithium out of the ground to supply the demand, because the demand curve is growing at such a rapid pace. And that's evident. I mean, if I would have gone to the work truck show 5 years ago, there may have been some people talking about batteries, and there may have been 1 or 2 battery companies there. But I mean, it was everybody. I mean, Workhorse was there, BYD was there, Canoo was there, Ford Pro, Toyota, Hyundai. They all had battery technology there. That's just a completely different paradigm than we were in. I mean, even just before COVID, I mean, EV was coming, but Elon Musk hadn't hit the scene yet, right? Yeah. And he's really been the hammer that's kind of shattered the perspective of EV. And that's fine, right, wrong, or indifferent. It's here. It's how do we adjust and how do we help succeed with it being here? And I think one of the things that I'm curious about is kind of, personally, I'm curious, and this is where I'd like, Anthony, maybe you could speak to this, is I am curious about, I have my theories on the next evolution in batteries. I do think batteries are going to stick around, and I think they're going to evolve mostly in the chemistry. And I didn't know if you had heard of new battery chemistries that are out there, sodium, being one of the elements that I think would be very interesting to explore as far as a battery goes, because we put salt on the roads. Why? Because it absorbs the energy into space, displaces the energy, and that melts the ice. So we know that sodium and salt is a fantastic energy conduit and storage vessel. And so my question to you is, what do you see in the next 5 years on the EV space as far as the evolution of batteries? I think that the structural support of EVs has to be explored, but I think EVs hit faster than the ability for people to change their paradigm on how they build things. And so that's going to adjust. I think the technologies exist now to supply battery technology with what they need to support the growth of vehicles, make batteries more efficient in the existing technology. But what I'd be curious about is what your take is on future technology for batteries.
So there's a, oh, go ahead.
No, I was going to say, Anthony, before you answer that, I want to mention Anthony, because I didn't finish your whole bio, but Anthony has, and did I get your Vicari?
Yeah.
Is that right?
Correct.
Okay. So Anthony has an MS in material science from Carnegie Mellon University and a BA in chemistry and physics from Harvard University. So Peter, he should be able to answer your question.
Excellent.
Thanks. Yeah. So given that there's a lot of development being done in the battery space, in recent years, a lot of what I've looked into has been for stationary batteries for grid storage. A lot of the new chemistries that are coming out are starting to be more optimized for that as we put more renewable power on the grid. There are some that are promising in terms of having higher energy density or similar power output per unit energy density as lithium ion, but getting to a point where that's ready for use in a mass market electric vehicle is a very long road. And I think we're likely to see lithium ion in some form stick around for a long time.
Sure.
We're going to see improvements in the energy density, whether that's from silicon anodes or replacing graphite or more pure lithium or all solid state batteries, things that can improve the energy density on the margin. But despite the fact that it does make a car so much heavier, right now lithium ions really are the best option for maximizing how much battery you can put in the vehicle. So, whereas a lot of the other chemistries really are not quite there yet.
So have you seen anything kind of and I'm not saying take necessarily lithium out of the battery, but what about the cobalt? Have you seen any kind of replacement for that material? Because that's really the most concerning aspect. So what I understand, and this is where maybe you can help me out too. So I'll give you the lack of knowledge that I have, and maybe you can fill in some gaps for me. But I'm going to lay it out there. So my understanding of lithium mining is that lithium, even though it's qualified as a rare earth, is not necessarily rare. It actually is quite an abundant element. It's just nested together with a lot of other elements. And so the process of excavating or pulling lithium out of the ground can provide a wide variety of environmental impacts, including the exposure of uranium or cobalt. And there's a higher demand, and this is an economics play, right? If there's a high demand for lithium, but not really a high demand for the other 4 or 5 elements that they're pulling out of the ground, those elements get disposed of because lithium is the high dollar value item, and they can't just dump those other items onto the market to be sold. Otherwise, uranium drops in price, cobalt drops in price, and the economies begin to get weird.
That's a good point.
And so when you have an abundance of all of these other materials, they're being disposed of, and I don't know how they're being disposed of. It's a question that I would like to see a documentary on, because I think it would be fascinating, because it's going to be a black eye for the EV industry whenever it does get exposed. I don't really know anything about it. I just know the actual facts that they are nested together, and that there's not enough people consuming cobalt and uranium to equalize the consumption of the lithium that's coming out of the ground. So my question, and I know that's a long exposure to my lack of knowledge of what's going on, but my question is there a replacement potentially for the cobalt that's in the battery, where we don't have to mine that as well?
So the short answer is yes, there are a lot of people working on alternatives to get rid of cobalt. There are lithium ion battery chemistries out there today whose cathodes don't use cobalt, that are typically not quite as high performing, but they're not that far off. But if you're asking about what's going to be in use in vehicles within 5 years, then that's a hard sell.
Come on, pull that crystal ball out. Come on, pull it out.
No, I'm saying that we can move away from those, right? There are other alloys. There are ways to do it.
Okay.
We're getting a lot better in recent years at designing new alloys for batteries and otherwise with custom properties, right? The material science and the metallurgists are very good at that. But it's a process that takes time and a lot of iteration, especially if you need it to perform for 5,000 cycles and never catch fire on the road and things like that. Those are much higher bars, which is again why you don't typically see those types of batteries starting off in the EV market, at least not yet.
Right. Okay. Have you seen, now here's another question. Let's open up the aperture. Have you seen out there interesting technology surrounding the use of battery case, right? We've got EV, we've got backup storage at the house. Have you seen anything else where batteries are like, do you really think they're going to be in urban air mobility? Do you really think it's a solution for flying anything, putting anything up in the air? Are there other applications for battery power that you see that would also be potentially upset the turnip cart when it comes to market demand?
I'm a little skeptical on air mobility with batteries unless it's extremely.
Would be too.
I think there are some use.
My battery car goes out, I just stop. My battery plane goes out, and I'm done.
Yeah. I'm not doing the testing on that one.
No. There are some use cases in the world where there's very short haul flights today. So we know there's some market for it. So I think we will see it to some degree. But in terms of scale, it's never going to be, or at least not in the next few decades, going to be close to what we need for the other markets. I think it's going to be, I don't think that's going to be enough to disrupt. I think maybe for medium duration flights, we'll see more use of hydrogen, and for longer flights, we're probably going to start seeing more synthetic fuels get adopted. Policy and technology are pretty much pushing in that direction, whether that's bio-based or electrofuels. But I think we're still going to be using liquid fuels for those for quite a while.
So let me ask you this now. Now here's another macro question, and this is something I'm really genuinely curious about. I know there's a lot of people that know enough about EV that when they begin to pull the onion back, these are the questions that come up. Okay, so power grid, right? So the debate is, all right, well, we've got this EV. Is it really helping us? Like, are we really being more efficient? And the answer is yes, it's a more efficient mode of transportation. Like, you put a battery on, you're utilizing functional energy more. You still got to put the energy into that battery, right? And that's the question. So clearly, if all of the demand was fulfilled for EVs immediately, our power grid would not be able to sustain that.
Correct.
But it's not. It's trickling into the market. And it's not trickling in the market because of some type of nefarious scheme or the ability to ramp up power at the same time. It's trickling into the market because our supply chain can't supply the materials fast enough for them to build the vehicles or the batteries. And again, that goes back to the demand of lithium that'll solve its own problem. But my question for you is on energy itself, like as far as it goes to moving stuff or people around. What is your opinion of energy, and what do you think we need to be looking at as far as the development of technology around energy itself? Like, that could be on the grid or new energy. Because I know nuclear fission is out there now, which is, I know that's a long way off.
More fusion,
That's wicked cool. I mean, that's sustainable energy for everybody forever.
Yeah.
So the high level answer there is that I don't think there's any real good path to decarbonization that doesn't involve tripling to quadrupling our total electricity production in the next few decades, because you have to replace the things we get from burning fuel from other sources, and that's going to be electricity. There's some room for expansion of hydro. There should be plenty of room for expansion of nuclear fission, but politically that's a tough sell. Right. Fusion is something where there's been a tremendous amount of progress at small scale, but it's a technology that in many ways often works better at big scale, just based on the physics of it. So
that's the stuff that was going on in Idaho, right?
Yeah. So that's going to be something where it's really going to be a matter of financing and political will, how long that takes to make the remaining steps towards commercialization.
Okay, but, Anthony, can you explain the difference between fission and fusion?
Oh, sure. So just basically, fission is splitting stuff apart, and fusion is joining stuff together. So fusion, you're taking some sort of light elements, whether that's hydrogen or its isotopes or lithium or boron, and making a heavier element out of it. Whereas that's fusion, and then fission is taking heavy elements like usually uranium, and then splitting it into smaller atoms, lighter atoms.
Okay. And then so basically with fission, you're taking an unstable element like uranium,
Yep.
and as it's shaking, you're shooting stuff into it, and as it breaks apart,
Pretty much, yeah.
it's creating energy,
Yep.
and as heat, which then powers a steam turbine. And that's, a lot of people misunderstand the use of nuclear power. In the very simplest form, you're just creating a lot of heat so that you can power a steam turbine. So all the smoke,
very fancy way to boil water.
Yeah, and everybody kind of looks at those giant stacks and they're like, "Oh, it's the end of the world." And what's coming out of those stacks is steam.
Steam, yeah.
And so that's a good paradigm shift. But I always get fission and fusion confused. I think that was helpful for me to understand. Can you explain the theory then on? And Jonathan, I know we're way off topic on.
No, yeah, no,
we'll dial it back in. But
pulling stuff out that I would have never. I'm here thinking about battery enclosures, and you're talking about, cobalt and lithium. So that's awesome. I love it.
But on fusion, then you're pushing elements together and condensing those elements into something more, essentially forming a small star. And that's the fear, right? You get a small star and you burn it up, and it turns into what? A black hole. And everybody's afraid that they're going to start turning these little black holes all over the country. And I get it. It's not that simple, but that's the logical fear that people go to. So my question for you is, when you're pushing those elements together, what are you doing there? Like, where is the energy? What is the energy? Is it still boiling water, or are we looking at something completely different?
Fundamentally, yes. You're still releasing heat and then using that heat. Yeah.
Good. And then the reason it's sustainable?
Because it's a very abundant fuel source. You're used in many cases. This is a question, actually, because there's lots of different types of fuel cycles in the fusion research. Some use some pretty rare isotopes of elements, and some use more common ones, but which are going to be easier to source, which are more abundantly available. There's a lot of open questions. So if you look at hydrogen, there's deuterium, there's tritium. If you look at helium, there's helium-3, there's isotopes of boron and lithium. And so some of those are more abundant than others. Some of them are easier to use in fusion than others. So that's a big, actually open question still.
Okay. That's interesting.
Most viable.
Okay. So now we're reeling it back. Okay. So we're making the connection. So now we have our macro problem, the power generation. Okay. That's a problem that's going to affect everybody. Our power grid in the US is not as robust as I would like to see it to be, energy independent and all that stuff. Okay. But we're taking all of that power that we're creating and we're passing it down to people to use in their battery vehicles, use in their houses, to use everywhere else. And what we're proposing in the composites industry is that, and this is what was shocking to me, is that we have a good form of dissipating that energy into motion to move stuff. Okay. That's basically what we're doing. We're taking energy off the grid, we're putting it into a capsule, and we're taking that capsule to move stuff. And it's the same thing with embodied energy within a liquid fuel source with ice. It's just the engines that we have aren't efficient enough to be able to burn the fuel at the same, because the energy density within that fuel is still solid. It's still a great energy density within a diesel or a gasoline. And petroleum is fantastic for putting that energy out. Our ability to burn that in an efficient way that translates into a powertrain, that's different. And so electricity in electric vehicles and battery vehicles do a much better job of translating energy into motion right now, at least in my opinion. And that's where I think it's going to continue to grow. And that's where I think you can't really debate whether EV is going to be here or not, because it is. You go to the work truck trade show and it was everywhere. The issue,
that's not, you can't get into that debate. We have to know that it's coming regardless. So,
and it's coming because of market demand.
Absolutely.
The consumer is drawing it in. So the consumer, and I'm not trying to offend anybody, the consumer is not knowledgeable enough on fuel sources and infrastructure to make a qualified decision on whether they have an opinion on whether it's EV or not.
That's
what
right.
they realize is they can go a lot faster, a lot quicker, and not have fumes or anything else. And so the perception of green is nice, and the ability to have power on demand is nice, and plug it in so they never have to visit a gas station again. All those things are nice to have, and it's converting people. And so the market is beginning to demand this type of energy source for moving themselves and others around. My question is, we need to get from producing those structures that are being moved around to structures that are going to be more efficient so that we can help our power grid out, right? Mm-hmm. So until nuclear fusion comes online, we need ways to help that power grid out. Like, we can't just keep burning coal to supply battery power, because it defeats the purpose.
Right.
So I do think that, at least for the next few decades, most of the growth in that electricity production is going to be coming from solar and then wind. Those are currently the cheapest energy sources in much of the world today per kilowatt hour. Okay. That also introduces the need for grid scale storage, which is probably going to be chemistries other than lithium for a lot of purposes.
Mm-hmm. So battery again, not battery, wind again. That's great composite technology, right? So composites are
absolutely
all wind. But what do composites do? They bring longevity. Mm-hmm. Okay, so they last for a really long time. But the wind industry doesn't have. So wind is fickle. Sometimes it's hot, sometimes it's not. Not temperature wise. Sometimes, I mean, they're producing a lot, and sometimes they're not. But they don't have the documented evidence to say how long a wind blade should or should not continue to be in the field. So my issue right now is repowering. Mm-hmm. So when you go to repower a wind blade, you're taking a material off of that energy source that is dramatically hard to do anything with, because it was designed to last as long as possible. And so now you have a material fundamentally that's supposed to last forever that is now being taken down, not for no other reason than we don't know how long it would last. And there's embedded technologies that can come to bear on that. So it's the same. The reason I'm bringing it up is it's the same stuff that's going into what I propose would go into the vehicles. So, but what I'm saying is there's going to be an issue with wind as a renewable resource going forward, because of the fact that it's going to have a black eye when you go to GE or you go to Siemens or you go to these other companies, and they have acres and acres of expired wind blades with nowhere to go and put them and nothing to do with them.
Yeah.
So I know that's an issue. I don't want to broach that.
We had that discussion last week on the, what to do. One of our guests came on, and what to do with, end of life on these blades and so many other applications related to wind energy, but particularly the blades. I mean, they go to, right now they go to landfills when they're done. So,
and here's a shout out to a couple folks out there, like ACCR is doing some great work in trying to recycle wind blades. Green Tex Technologies, but their recycling is more of repurposing.
Right.
Martega out in Colorado is also looking at some recycling for composites, and I think those are all great technologies, and they're budding, and they're fantastic. But composites, unless you figure out a cheap way to break the cross linking, is going to be turning it back into powder, and then trying to add the powder into something else to make something else better. But all that to be said, like, that is going to be something that is going to be an issue for converting EVs into composites as well. And so there are solutions out there and that's where have you come across any, and I want to use the term green loosely here, because green is not really what I'm looking for.
Right.
I'm looking for something that is robust enough to match a thermal set and its properties, but at the end of its life can be unchained and taken apart to put into something else. And I'll use an example real quick, maybe to get everybody's juices flowing. So Arkema creates a material called Elium. Yep. Elium is a thermal setting thermoplastic, has tremendous impact resistance, can be manufactured very similar in the same form and fashion as a thermal set like a polyester, but the cross-linking hasn't happened. So it can be recycled.
Repurposed.
Correct. And then the fibers can be gathered a lot easier, and then the fibers can be put back into something else. Right. Have you seen anything else like that could provide the same structural vitality that you would see from a thermal set material that can be purposefully used for EV?
On the material side and the composite specific side, no. But I would say that in a more general and higher level sense, there's so much work being done now to improve recycling of regular plastic waste and municipal waste and industrial waste that can decompose organic material in general and separate out any inorganics from it, things like waste gasification, anaerobic digestion, and other things. If those scale up enough, that might be a way to reconvert even thermosets into something that can be reused, whether that's syngas or
Okay.
blue food or something like that. There are
Is that
other
kind of like thermalizer? Is that the thermalizer project?
gasifiers, pyrolysis, all of
Okay.
those kinds of technologies. Yes, in principle, it doesn't solve the problem. You still want to get the best composites and recycling technologies for composites that you can,
Right.
but eventually there will be an end of life because polymers
Sure.
degrade.
By the time composites are at the end of their use life,
Right.
there will be. The issue is that it's
Right.
we're accelerating that conversation largely because
Right.
of the wind blades.
Yes,
Right.
exactly.
Yeah, and I've seen the repurposing. It's interesting because they can't, and this might be a rumor. So if you guys know better than I do, fill me in. But I have heard that you cannot sell or buy the repurposed fiber from overseas because it looks like cocaine. It really does. When you grind it up small enough, and there's
Don't they have dogs for that? I mean, come on.
right, yeah, but you don't want dogs snorting composites. I think the glass would probably shred their lungs pretty well. It's hilarious talking about this too. That new movie, that Cocaine Bear, which came out of the East Tennessee area, Jonathan. I don't know if you met this
I've heard about this story back in the 80s.
East Tennessee. But they can't. They literally can't move ground up wind blades around and sell it because it looks like cocaine, and it's. I don't know if that's true or not. If you've heard anything towards that, but I thought it was funny.
I haven't, but there are definitely technologies for relatively portable scanners that should be able to tell the difference between silicon or carbon and something more.
So then let's dial this in even further. Okay, so we talked about macro. We kind of dialed it in on some of the issues that we're talking about and some of the things that are potentially inhibiting development of new materials in the movement space.
Mm-hmm.
Where do you think on an EV or and some other type of structure, where do you think would make most sense for composites to be applied right now?
So right now, what we're seeing is that where people are using composites in automotive today, it's in spaces that are often less structurally critical because you can, not necessarily have to have them be the most strong parts, even though in many ways composites can be stronger than a lot of metals. They're not always. One of the other changes when you go from an internal combustion engine vehicle to an electric vehicle is the change in the weight distribution, whether it's front to back or top to bottom. And carefully using your composites can help you improve handling. It can help you improve aerodynamics. I think there's been a lot of talk about that spinning mass over the years, whether you can use that in wheels, because then you get outsized benefit from smaller amounts of lightweighting. And I think that's where I would see the first application. It's how much can we get out of each pound of lightweighting we do? What side benefits can we get? Things like that.
And you hit an interesting topic too, because it's the whole pound of rocks versus a pound of feathers. Which weighs more? Well, they weigh the same, right? But you just get a whole lot more feathers.
Sure.
It's the same kind of interesting thought process when you talk about composites versus other materials, other structural materials. Because let's say a pound of carbon fiber, there's a lot more of a pound of carbon fiber than there is for a pound of steel. So, in a pound of carbon fiber per mass, the mass is going to be stronger than the mass of potentially steel. Potentially, it depends on
how you use it.
Exactly. Right. But when you increase a composite to match the modulus, and there's an engineering term for us, and I'm not an engineer, so I'm going to define modulus as stiffness.
Yeah.
I know that, and again, I'm not an engineer. So, but if you match the modulus of a composite to a steel, that composite is going to be a lot bigger than steel because it takes more of it. Now, when you match the composite, and I'm going to give a shout out to Scott Lewitt at Structural Composites on this one, because he's the one that I've heard this about 15 times from him, and it took about 15 times to get through my head. But when you match the modulus of a composite to the modulus of steel or aluminum for that matter, the composite becomes very strong. And when I say strong, it doesn't mean necessarily just modulus, right? There's other characteristics and strength that come to bear, like the ability to receive impact and dissipate impact, right? Impact resistance. All those things become more, all of those characteristics get amplified when you have to match modulus. And stiffness is important for vehicles, and I think you hit on that, right? In order to improve some of the ride, you can take carbon fiber, and it is incredibly stiff, and the modulus is incredibly stiff, and you can put it in areas that stiffen the ride up. And I think what would be interesting would be where applications on a larger footprint would be, because I know now, and I'm going to go back up to come back down. So I'm going to go up to the fact that the design for vehicles right now is an assembly process, which means there's a lot of different components, right? Your axles and your building components aren't all the same. Let me qualify that again. So what I'm talking about is converting to a monocoque, right? There's not a lot of monocoque structures out there. Electric vehicles provide the ability to do that, but they haven't even converted. Most folks haven't even converted to a monocoque design yet. And so you still have when you connect the wheel to a vehicle, you're using parts that have to be assembled together that aren't part of the structure. And so the communication of energy from the vehicle to the wheel to be able to move the structure is very difficult. And it's one of all of the engineering for a vehicle comes down to the impact of the rubber on the road. And that's where the rubber meets the road, right? And so when you start going from the rubber to the wheel to the vehicle itself, there's just not been any conversion from ICE to battery on just a simple process of redesigning the structure itself. So that's going up. Now I'm going to come back down. Do composites play, or could they play, in your opinion, in the monocoque design? Would it allow for a better design that could functionally accelerate the development of those types of designs in vehicle manufacturing? And if yes, how do we get that out there? How do we do that?
Fundamentally, yes, but I don't think anyone has gotten a good enough solution to repairability during the vehicle's life to really make it viable at scale, right? People want to be able to replace individual parts and repair. What can you weld? What can you fill in, buff out?
Right.
That's a much harder problem with composites.
What if it became cheap enough?
Then that would be a totally different question. I mean, if it was free, you'd use it, right? Like, it's not.
No. So let me explain. And so when we work with Wabash, and here's a shout out to Wabash for their innovation and all that great stuff. Wabash Trailers is converted into a composite refrigerated trailer. Mm-hmm. They have found that they can get close to or achieve cost neutral basis on producing it compared to their other trailers. And the reason they do that, and this is the reason it's relevant, is they in Trinity Rail can echo this. They're doing a lot of great things in composites as well. But you're reducing part count, you're reducing labor, you're reducing work in progress, right? You're improving workflow and throughput. And so you could theoretically get to the point where, even though a pound of composites is going to be more expensive, depending on the composite, than a pound of steel or aluminum for your design of your frame. But if you could produce that stuff fast enough, cheap enough, then maybe the car becomes disposable, right? Then you get the recycling issue again, but we don't need to get back into that. Let's just say, from the consumer's point of view, now you've got a strong, stiff vehicle that can go on a design that makes it more efficient. And do you think that that's possible to get to that point where we could say, all right, well, all these seats bolt on, let's just bolt everything off, right? All of the pretty pieces, and dispose of the monocoque, and then put another one together? And is that fast enough? Is it feasible enough? Because essentially it's a golf cart, right? We're talking about golf carts here, right? There's just not a lot of stuff that's going into that. So could you get there? I mean, is that a plausible assumption or thought process?
I think for me, the thing that pulls in the other direction is that over the next decade and a half, we're going to see enough growth in autonomous vehicles and smarter vehicles that, if anything, that's going to push the price of an individual vehicle higher in a lot of cases, and push us more towards shared mobility and vehicles that could use a lot more of the time, which would make the cost of the material less of an issue. But in the current way we use cars as private vehicles that we drive ourselves, then yes, I do think it is theoretically possible something could get cheap enough. But
no, I think you bring up a good point too. Okay, so this is paradigm shifting. All right, you brought up an excellent point, and I'm glad you did that. So you're talking about the fact that in the future, we may not even own vehicles. Not that the vehicles won't exist, but we won't need to, right? Why do we need 2 to 3 vehicles sitting in our driveway when I can buy a vehicle share? And then when I want to go somewhere, it's as simple as pulling up an app and saying, I want to go here. And it's free for me because I pay a monthly subscription for an X number of miles, right? And so a vehicle comes up, picks me up, drops me off. And then I really don't have the need for it. It's like Uber meets autonomous driving. But then all of this stuff, it all comes back down to money. All right. And
the bottom line rules, Peter.
It does. As much as I'd like to live in a nuclear fusion facility out on Mars, it takes a lot of money to make that happen.
Yeah, right.
But the problem that I see right now, and this goes back to the repairability, I don't see insurance companies footing the bill for composite vehicles, but I do see maybe the answer to that being exactly what you talked about, is the autonomous driving. Because as much as people are afraid of autonomous driving, because they're like, oh, the robot can't drive better than I can. In fact, they can. Okay. So in fact, the fact is that robots are going to err far, far less than humans by a large margin. And so I get that we want to have control, but the fact of the matter is that AI is going to be better drivers. So will the insurance companies now begin to provide less expenses for an AI? And will that support the innovation of composites? Because composites are going to be more expensive to insure than their alternatives, because there's not an infrastructure around repairing those like you talked about.
Absolutely. Yep. Yeah, you nailed it. Guys, this has been, I'd love to keep talking, but we're getting short on time, man. We're going to have another, maybe a future discussion on, like a futurist episode on this show, and bring you guys back. This is fun conversation.
It is. It's good. I like
guys, I want to mention, Peter, and you brought up a really good point earlier. It's like consumers driving, if you're thinking consumers out there are driving the momentum for any type of industry change. I always go back to Steve Jobs, where he said, consumers don't make my decisions. I don't make decisions based on what consumers want, because consumers don't know what they want. And it's true in a lot of cases, especially when it comes to technology. I don't think anybody could envision 1,000 songs in your pocket at the time, but he made it happen. So that's how it goes. Typically, we need the innovators out there, people that are in innovation, bringing that to the table, because a lot of times we don't know what we want. We kind of do, but we don't know how to put it together. So,
right.
So good discussion, guys. Peter, I want you, each of you, to mention where obviously they can find out more. Peter, we'll start with you. How can they learn more about, get more information, visit CAG, throughout your website and your contact information?
So happy to. So I'm on LinkedIn. I think that's what generated this conversation. So feel free to look me up, Peter Hedger. I have a dad on LinkedIn who carries my name as well. You'll just have to sort through it.
That's right.
And then compositeapplicationsgroup.com, or you can email me at peter@compositeapplicationsgroup.com.
Right. Anthony, how about yourself?
Applications is plural.
Oh, yeah, that's right. Plural. And we'll put a link. We'll have a link on our show page for each of you guys. So
thanks, Jonathan.
But Anthony, also, I want to throw that out to you, and I want to connect you guys too on LinkedIn. Anthony, how can our listeners find out more about what you guys do over at Clean Tech? I know I didn't give you a chance to give a little byline there, although I gave some information on yourself, but give a quick summary on what you guys do and how people can learn more.
Yeah, so you can find me on LinkedIn as well, or you can go to cleantech.com and learn about Clean Tech Group. We are a research and consulting firm. We also have 3 events a year, the Clean Tech Forums in North America, Europe, and Asia. So we have a lot of ongoing coverage and everything from energy and power, materials and chemicals, resources, environment, transportation, logistics, even agriculture and food. So you can go there, learn about us, and get some information on how companies are working to meet their sustainability goals and what emerging technologies are out there helping make that possible.
Very good.
Great.
Gentlemen, thank you both so much. This has been a fun discussion. We're going to have to do this again, continue, because there's so many ways we can go. I think there's so many opportunities in the EV market for us. I always think the low hanging fruit is always in battery enclosures because of, the thermal all the heat buildup and obviously the light weighting. But, as technology continues to improve and innovation continues to make things easier, lighter, more price efficient. I mean, for the consumer, more fuel efficient, then things are going to get better. So guys, thanks so much for your time today and look forward to having you guys back on sometime.
Yeah, great. Jonathan, thanks for the opportunity. Anthony, it's nice to meet you.
You as well. Nice to meet both of you.
All right.